Good afternoon and welcome to another episode of The Angry Astronaut. Been bringing you this content fast and furious lately because the news has been fast and furious. I was hoping actually to bring you this episode a couple of days ago, but things with Virgin Orbit have really been attracting my attention, especially considering that against all odds, they seem to be preparing to launch again in spite of the conditions at that company and the fact that they are missing 85% of their employees, but they still seem very determined to prove that they can do all of this. If you're interested in those details, I have those videos linked at the end of this one. So it's been a long time since I've talked about Jupiter and especially Jupiter's moons on this channel, and it's something that's extremely interesting to me and always has been, simply because a lot of people have argued in the past that we will never visit Jupiter, at least human beings will never do it, and certainly colonizing the moons of Jupiter will never be a realistic thing, simply because Jupiter puts out an enormously powerful radiation storm on an ongoing basis associated with its incredibly powerful magnetic field. Indeed, if you got close enough to Jupiter to be in orbit around the moon of Io, for example, the radiation would be enough to give you a lethal dose in just a few hours. It is a very deadly place for human beings to go, so why would we ever want to explore these moons, at least in person, and especially even think of colonizing them? Well, we have a new probe from the European Space Agency called JUICE, the Icy Moons Explorer, and what it's going to be doing is checking out the environment of these moons, or rather 3 of the 4 moons, in greater detail, especially in terms of composition. Its main mission is to determine just how habitable these moons might be, to try to find out more information about their subsurface oceans, because we suspect that there are subsurface oceans, not only with Europa, but also with Ganymede and Callisto. And where there is liquid water, there may also be life. But in addition to that, this probe is going to determine just how habitable these moons might be. With composition comes information for in situ resource utilization. And these moons are very, very rich in one important resource that, of course, will ensure the survivability of a human colony, and that is water. But what about the radiation? How do we survive one of the most lethal places in the solar system? Oh, and once again, please like, please subscribe. Thanks so much to my new viewers. I've accumulated well over 14,000 new viewers in the last few months. I'm so happy to have all of you new subscribers. And also, please, everybody, check those notification bells. Very important, so that you get notified about every video I put out, not just what the YouTube algorithm tells you that you want to watch. And finally, if you want to support this content, especially my upcoming trips, all the links are in the description. Let's get on with the Icy Moons Explorer. Now, first of all, since this is an ESA mission, it's going to be using an Ariane 5 rocket. And I've been very hard on Arianespace in the past, but I really can't be too hard on this rocket. Its level of success, its reliability is legendary. Only the Atlas V has a superior level of performance. Indeed, this rocket, for a considerable amount of time, was the most powerful rocket on the planet until Falcon Falcon Heavy and SLS came out. Of course, Starship has yet to fly at the time of this recording, but it would be a serious mistake to underestimate the capabilities of this rocket, especially its ability to fling payloads out to geosynchronous orbit or to interplanetary destinations, which is why this rocket was selected for the James Webb Telescope and why it was also selected for the Icy Moons Explorer. So the Ariane 5 is going to provide the Explorer with a tremendous amount of thrust, at least by early 21st century standards, about 3.5 million pounds, but more importantly, its Vulcane engine is going to be able to provide it with a great deal of thrust for a very long period of time. We're talking a total burn time of 540 seconds, and then the second stage will kick in, also with the capability of burning for well over 400 seconds. All of that burn time is going to allow it to push the Icy Moons Explorer all the way to Jupiter. Eventually, and that is a big word that we need to keep in mind. It's going to take 8 years for the Icy Moons Explorer to arrive at its destination. Why so long? Well, first of all, it's because of the nature of the mission. JUICE is supposed to be orbiting Jupiter, or more specifically, orbiting the moons of Jupiter. If it's going to do that and therefore be captured by Jupiter's gravity, you can't be going too fast like Voyager 1 and 2 that carried out these amazing flyby maneuvers. Instead, you have to go a little more slowly. And on top of that, of course, Jupiter is not very well positioned compared to the way it was during the time of Voyager to get there expeditiously. But it will get there eventually, and with the assistance, as I'm sure you've noticed from this animation, of a lot of planetary flybys. It's going to fly by almost every planet in the inner solar system, and also use the sun to increase its velocity as well. And there's another factor impacting the transit time between Earth and Jupiter as far as JUICE is concerned, and that's the size of the spacecraft. JUICE is far bigger and far more ambitious than Voyager ever was. Voyager clocked in at 721.9 kilograms at launch, whereas the JUICE, well, get ready for this. The fuel tank alone on JUICE weighs over 3.6 metric tons, and the entire spacecraft weighs nearly 6 metric tons. We're talking over 8 times as heavy as Voyager was, which means, of course, that this is a much more ambitious spacecraft packed with scientific instruments that are going to tell us a great deal about the moons of Jupiter that we don't already know. This incredible suite of instruments include the following: the 3GM, or the Gravity and Geophysics of Jupiter and Galilean Moons, which is a radio package that allows them to study the gravity field of Ganymede, the extent of the internal oceans on the icy moons, and also the structure of the atmosphere and ionosphere of Jupiter and its moons. Then you have the GALA, the Ganymede Laser Altimeter, which will study the tidal deformation of Ganymede and the topography of the surfaces of the moons. On top of that, you have the JANUS, which is an optical camera system, which will study global, regional, and local features, as well as map the clouds of Jupiter. It will have a resolution of 2.4 meters at Ganymede and about 10 kilometers at Jupiter, giving us far more detail than we've ever gotten before. Then we have the JMAG, a magnetometer, which is equipped with sensors designed to characterize the Jovian magnetic field and the interaction with Ganymede. By the way, if you're wondering why we're talking about Ganymede so much, well, it's because after this probe studies all of the moons in detail, well, except for Io, that is, it's going to enter into a long-term orbit of Ganymede. After that, you have the Moons and Jupiter Imaging Spectrometer, which will observe cloud features and atmospheric constituents of Jupiter, and also the exact composition of the ices and minerals on the moons that it's going to be studying. That is to say, Europa and Ganymede and Callisto. On top of that, you have the particle Spatial Environment Package, which is going to be studying the high-energy radiation environment of Jupiter. Then you also have the radar for icy moons exploration, an ice-penetrating radar that will study the subsurface structure of the icy moons, including hopefully the oceans, to a depth of around 9 kilometers. Then you have the radio and plasma wave investigation, which will characterize the radio emission and plasma environment of Jupiter and its moons using a suite of sensors and probes. Then the sub-millimeter wave instrument, investigating the temperature structure, composition, and dynamics of Jupiter's atmosphere and the exospheres and surfaces of the moons. And finally, the UV imaging spectrograph to characterize the composition and dynamics of the exospheres of the icy moons, to study Jupiter's aurora and to investigate the composition and structure of the planet's upper atmosphere. And okay, I lied. The mission's also going to carry out an experiment called PRIDE, which uses the telecommunication systems of the spacecraft together with radio telescopes on Earth to perform precise measurements of the spacecraft position and velocity to investigate the gravity fields of Jupiter and its moons. That's a lot of stuff, and I hope explains why this thing has to be so big and so heavy. We are going to learn so much more about the moons of Jupiter than we have ever known before because of this extremely ambitious probe, assuming, of course, that it successfully arrives at its destination and it functions as designed. There is a lot riding on this thing, and of course it's going to be operating in a very hostile environment. High radiation areas can be very hostile to spacecraft, just as it is to human beings. But what are the moons that it's going to be examining, and what's so special about them? Well, the one that you probably heard the most about is Europa. We are almost certain that Europa has a subsurface ocean, something that planetologists would have considered to be absolutely impossible a few decades ago. But since we've learned about how gravity affects the cores of the moons of Jupiter, that is to say, liquefies them, or in the case of Io, creates an extremely violent volcanic system, we've also learned that liquid oceans can indeed exist inside these moons. Liquid oceans that may also be rich in salts, and if they are rich in salts, that can create chemical reactions that could support life, similar to the life that clusters around hydrothermal vents in Earth's oceans. As a matter of fact, this ocean has probably been active for many hundreds of millions of years, if not billions of years. That being the case, evolution has had a long time to work beneath the surface of this moon and could have created multicellular life in addition to bacterial life. Some of the most amazing forms of life could exist beneath the surface of this moon. And interestingly enough, Jupiter's radiation actually makes Europa an even richer environment for life. How so? Well, because Europa is constantly bombarded by radiation and cosmic rays, this breaks up the chemical bonds of the ice, and these reactions produce oxidants, which are a key ingredient for life. And since Europa's surface is constantly being renewed by icy tectonic activity, that is to say, ice canos, these oxidants get dissolved in the ocean, where they can react with hydrogen and other chemicals are produced. This rich biotic soup, so to speak, is very similar to the type of environment where Earth life involved as well in our oceans. Moreover, scientists have determined that as a result of these chemical reactions, roughly 10 times as much oxygen exists in Europa than hydrogen, which is about the same ratio that characterizes Earth. It is entirely possible that the oceans of Europa are home to an ecosystem every bit as rich as the oceans of Earth. But of course, we're not going to find out all of the details until we drill through the surface of this moon, which JUICE, of course, is not going to do, but JUICE will be making 2 flybys of Europa, the closest of which is going to approach to a distance of only 400 kilometers. During this time, it will characterize the composition and chemistry of Europa's surface, hunting for substances that are essential to support life, in other words, biosignatures, and determining the source source of the moon's material, especially its volatiles and hydrated minerals. Europa may vent water vapor into space with plumes and geysers, and JUICE will search for pockets of water in the moon's shallow subsurface using unprecedented ice-penetrating radar, which I talked about before, revealing locations where the transfer of material between the subsurface, surface, and space may be especially intense. If JUICE can confirm the existence of a cyclical relationship between the surface and the subsurface of Europa, that is to say, a process that produces a wide variety of new materials that may also be extremely conducive to life, it will also very probably identify areas of Europa that are very likely to contain life, areas that will be searched in greater detail by future probes. But if the Icy Moons Explorer can track down these locations and associated biosignatures, we will be very close to confirming the existence of extraterrestrial life for the first time in human history. But there are other moons to be explored as well. Callisto is going to be explored in greater detail with a total of 21 flybys. Callisto may not be as active as Europa. It's further away from Jupiter, actually the furthest moon, and therefore the best moon for us to establish a colony on, simply because it's far removed from Jupiter's radiation. As a matter of fact, the radiation level at Callisto's surface is about 0.1 millisieverts per day, which is 10 times higher than Earth's average background radiation, but a pathetically small amount of radiation compared to interplanetary space or the surface of Mars. Callisto actually is a perfect place for us to set up a colony, and not just because of the radiation, also because it doesn't seem to be as geologically active. That being the case, you don't have to worry about ice canos suddenly destroying your habitat. However, there are a number of mysteries about this moon. First of all, it seems to have a magnetic field that is not generated internally, but might instead be generated by some sort of liquid body beneath its surface. In other words, some kind of ocean, although we're not really sure what kind of ocean might produce this particular type of magnetic field. In addition to that, as you can see, Callisto has these strange, dark, densely cratered plains, which show signs of unique erosion and degradation processes. We're not really sure how these formed, and JUICE may be able to discover a lot more about that as well. But the main focus is going to be Ganymede. Ganymede is the largest moon in the solar system. It's bigger even than Pluto or Mercury, and also it's the only moon to have its own magnetic field. JUICE is going to enter into a permanent orbit around Ganymede. Well, not a permanent, but a long-term orbit before it crashes into Ganymede to end its mission. And during this time, the Icy Moons Explorer is going to get a really good look at this incredibly mysterious moon. Because Ganymede has a magnetic field, that makes it unique in many ways. Not only does no other moon in the solar system have one, but also only two other solid bodies, Mercury and the Earth, generate magnetic dipole fields. Why does Ganymede, of all bodies in the solar system, have a magnetic field when even Venus and Mars does not? We also suspect that Ganymede might not have just one salty ocean, but many salty oceans in different layers beneath the surface. This was determined by the Galileo spacecraft's initial measurements of Ganymede's magnetic field, and also the Hubble Space Telescope's study of Ganymede's auroras, hinting the existence of not only just one, but several under-ice oceans. As impossible as this may sound, there may actually be multiple ecosystems beneath the surface of Ganymede, all having evolved independently. The mission's instruments will make detailed measurements of Ganymede's magnetic field and determine the electric currents at the moon to constrain the extent and conductivity of its subsurface ocean. In addition, it will use other techniques to find out the size of the liquid layer and the icy crust, including detailed measurements of the moon's rotation rate and a precise determination of Ganymede's gravity field and the shape and surface changes at the moon due to Jupiter's tidal influence. influence. In addition to that, the mission will of course use ice-penetrating radar to probe the moon's subsurface down to a depth of about 9 kilometers to determine the crust's minimum thickness and possibly detect liquid water in the shallow subsurface, and also to explore the moon's tectonic features. Ganymede's surface has a strange combination of old, dark, and densely cratered regions like most of Callisto, as well as lighter, younger, grooved regions which are more similar to Europa. This intricate pattern of grooves and ridges is thought to be due to tectonic activity, including icy volcanism or cryovolcanoes. So many things about this moon that we have yet to discover, so many things that this probe is going to uncover if everything goes well before it finally ends its mission by crashing into Ganymede. Hopefully this is a safe process. The ESA team has done everything they possibly can to purge the probe of anything that might contaminate it, but really, if you're going to put this probe in orbit around this moon, there is no other alternative. Oh, and by the way, Ganymede's distance from Jupiter combined with its magnetic field may also provide a great deal of protection for astronauts and colonists that want to establish a permanent presence on this mysterious moon. And of course, both Callisto and Ganymede are very rich in water ice, which is, of course, the most important thing that colonists can have in order to ensure their long-term survival. And JUICE will determine what other elements may be present on the surface of these moons for future colonists to make use of as we continue to explore the solar system. Smash that like, hit that subscribe, and stay tuned because I intend to cover this historic launch live, and as always, stay angry about space.